So I'm here to talk about recognizing and overcoming barriers to adoption of confidential computing. The talk is loosely based on an article I published on LinkedIn just a few months ago. And I will say that even since then, there's been some tremendous progress addressing precisely some of the barriers that I've been talking about in the article, so which is sort of in line with my expectations. This is a very rapidly moving field. So this is to say that these barriers I'm going to talk about are, while real, by no means insurmountable. And one final disclaimer, I here in the capacity of the chair of the consortium's governance, risk and compliance special interest group, and what I'm going to say is not in any way reflective of views, opinions, plans, etc. of my employer, which is a major financial institution. All right, so without further ado, so let's barriers. First of all, let's talk about confidential computing being unstoppable. And I really do want to emphasize this point because, why worry about the barriers of something that is not going to happen? This thing is going to happen. It's just sort of the function of how hard or easy is it going to be. And there are four factors really that, four, even five, that all point in the same direction. And one is that the customers will take data and use protections if they can have them. Now, it has to be relatively inexpensive and it has to be easy enough. But this is not a technology that a customer is likely to resist. It's a technology a customer is likely to adopt. Right, much like we had with data and use protection, much like we had the data and flight protection. Once available, we take it. So cloud service providers will want to reduce reputational and business risks of user data compromise because, back when I was at Microsoft, the risk of, a major breach that would, exfiltrate a lot of customer data, we used to call it turn your badge in event. Like we can all go home, nobody wants our stuff anymore. So confidential computing is, another protection against that sort of massive problem. So there's a host of independent software service vendors that also want to make a buck on the thing. Hardware manufacturers get a new market into which they can develop solutions and again make money and grow their markets. And much like we've had with data trust and data in flight, in use protections, I believe, and the reason I'm chairing the governance group, it will become a compliance requirement, and that's probably going to be the strongest driver. Now, the barriers to adoption, they fall into three broad categories. One that I will talk about it first because I believe it's the biggest one, and again, why I moonlight as the chair of this governance SIG, is there is a regulatory vacuum that we'll need to close that. The second one is there is a number of technology gaps that we need to worry about, and again, I will break those down. Finally, there is some industry fragmentation that we also need to worry about more because it's a friction point, not that there is a barrier to adoption. It's like, friction is like, driving with your handbrake on is really what I would refer to as industry fragmentation. And for the first two, I will make some predictions around how soon we're going to overcome them. I will not predict how we can overcome industry fragmentation because this is more of a call to arms. It will not happen unless people make a conscious effort to do so. All right, so hopefully I'm left Q&A. And without further ado, let's get into the regulatory vacuum. So here's the thing. Why am I putting it on top of the list? Well, that's because I'm saying even if every other obstacle were to magically disappear today, we would still not witness a big shift towards adoption of confidential computing. So why am I saying this? And the answer is basically kind of painful to hear because I'm a security geek. I want to see security technologies, see the light of day as quickly as possible. But the progress towards mass adoption, I believe, will be driven not by security, but by compliance. Also, the amount of money made in compliance dwarfs the amount of money, probably by 1 or 2 orders of magnitude. Now, here's the other thing. Like, I work for a major IT shop with probably 10 figure, if not probably 11 figure by now, IT budget. It's massive. And when you operate this many IT assets at scale, you have a myriad priorities, right? And and regulations, the desire to take on additional, frankly slim, except where warranted by like additional considerations outside of compliance. So for really, frankly, in the enterprise computing space, so certainly a secure multi-party computation would be some niche scenarios. That's of that. So the only niche multi-party, right? And popular statement with all the folks who are so passionate about the technology. But like from the like, if I put myself in the customer's seat, we already even if you educate people on what it is going to be very difficult to make this priority of doing the work exceed other priorities, like which are, of which there are myriad, right? So eventual driver will be compliance, and that's interesting in that when you talk to people who work with regulators, they will say regulations need to be technology agnostic. They don't want to have a prescription for confidential computing. They will want to say, if you mandate data in use protection, just say protect data in use, because technology evolves. And what you don't want is you don't want regulations that say, well, you must employ this particular type of technology. Any change in that kind of regulation becomes extra super expensive. But the good news there is the confidential computing will win that battle. The technology agnostic regulation will still land a vast majority of customers in the confidential computing space, simply because on performance, latency, complexity, adoption of existing technologies, like if you have your army of Python, JavaScript programmers who know how to write YAML scripts, etc., you're not going to get them to adopt fully homomorphic encryption. It's simply not going to happen. But if we need to comply with data and use protections, confidential computing supports all your existing tool chains. It supports existing commodity programming languages. It's the win all the way down. All right. So the bad news here is this is probably the longest barrier to adoption here. I'm talking about 5 to 7 years, because the regulators move slowly. We usually go from no regulations to some recommendations, and finally to requirements. That can take several years. Now, the good news, I guess, is that we have things we can work on in the meantime to get other things out of the way that would make eventual adoption easier. So let's get to that. So the technology gaps. The confidential computing, I would like us to think about it in terms of this jobs to be done framework. So what does a customer need to do in order to adopt confidential computing? I think majority of the scenarios will be lift and shift. So you take existing applications, you need to largely preserve architectural patterns for developing new applications. Retraining tends to be very expensive when you have thousands of technologists. Resulting systems can be very hard to secure if they don't understand what they're doing. So what we really need as a result is that we need confidential alternatives to all existing cloud building blocks, right? So large regulated institution will have applications numbering in mid 4 digits. You can literally have 5,000 applications. The number of regulators for a multinational institution can actually be in 3 digits. You can exceed 100. The number of pages, if you were to print them out and stack them, of various rules and regulations, they're in the thousands upon thousands of pages. So it's like a thick footprint. And then you have a presence in several public clouds, and you have presence, probably your own on-premises data centers. So what we cannot afford is a Cambrian explosion of bespoke per application contraptions, because that is not governable. It is not possible to make sense of it. So what do we need? When we're talking about infrastructure pieces and cloud services, well, what does lift and shift mean? This means it's not just my compute instance. It's not just my serverless. I also need to figure out what does the the confidential load balancer look like? What does the confidential web application firewall looks like? And then the other thing that I really want to talk about would be the performance. So there were some interesting talks in the first part of the day about the PCIe IDE and SPDF, the building blocks that will allow you to speak quickly to your peripherals. Today, without that technology, you actually do application level encryption. You have to encrypt all network and storage traffic inside your workload, and that can kill your performance. That's simply not, it's not acceptable. You cannot transition a workload into confidential until you get full hardware acceleration. And that means network and storage use, right? So the thing that you need is you need integration tooling, right? So you may have your Jenkins CI/CD pipeline, or whatever your customer may have, and that goes directly for you. You need policy and governance. Things we've experienced and is you can have your confidential, GPU acceleration, but PyTorch still will not work with it because it's not. I guess it's because it's not using CUDA. But the point is, you need to take your customer's existing workload, you need to move it into this environment with a absolute minimum of friction, and that's pretty much the only way that it's going to get enabled. And then finally, I want to talk about the shared responsibility model. So when your cloud service provider offers you confidential computing, it has to explain to the customer exactly what additional guarantees it offers. And the same goes for all platform as a service and software as a service vendors. So if I have an existing application and the counterpart dependency of this application is some kind of a SaaS offering that's accessed through some kind of API, where do we now draw the confidentiality boundaries? Like if our SaaS offering is saying we are confidential, well, it's how do I ascertain that? So I know this is a problem because even before you introduce confidential into this, the existing software as a service shared responsibility model is effectively unworkable. Like whoever drew these diagrams doesn't know what they're talking about. Like you cannot trust real world data to that kind of SRM where they say, oh, you're still responsible for it, except we're operating on your data. Confidential needs to be reevaluated in that context. So confidential in its DNA is a single user, a single CPU, single platform and Intel Speak device. Now, a real-world device is a CPU plus GPU plus NIC, and we need to, even if we talk about attestation, because yeah, fine, I can attest that I have a confidential VM, but confidential VM has confidential peripherals. Any cloud application is a compound thing. It has confidential serverless, and it has confidential compute, and it has confidential storage, and it has confidential middleware like load balancers, etc. So if I am, a remote user of a confidential application, exactly how am I attesting this? So we need to start paying attention to these things, and this is where I'm saying we need to take a holistic look at the problem, because gaps is what makes it impossible to deploy again outside of niche scenarios. So the good news is I think this one is going to be very, very fast to get through because of the work done both at the hardware level, at the higher levels, like we're going to get confidential containers imminently. We're going to get confidential serverless pretty much imminently. There is all this talk about now the next generation of confidential hardware that integrates devices and peripherals. I guess what's missing, we still haven't talked about how all of this is going to get integrated from the point of, as I said, dealing with compounding, etc. All right. So finally, let's talk about industry fragmentation. So, for the biblical context that most of us already know, people working together and speaking the same language can challenge God, right? And in the Bible, God gets upset. I don't think that's going to be the case here. If we can all speak the language and reach for the stars, I think we can. Right? And confidential computing is, because it's a hardware-based technology, and there are only so many, like low single digits, a few types of hardware between, AMD, NVIDIA, ARM, Intel. So the question then is, why is all this fragmentation? Well, so when I say, friction is bad for business, I basically say that it's like driving with your handbrakes on. So for one, cloud providers, sticky by intent, they are not really interested, as it's evidenced by identity access management policies, as evidenced by, everybody has their own container system, everybody has their own serverless offering. There is no interest in interoperability at that level. So if the same kind of fragmentation gets into confidential, well, you're just going to make matters worse. My poster child example for this is attestation verification, right? Today you get one out of Intel, one out of Azure, one out of AWS, one out of Google. They're all closed source. They don't share protocols. They test all the same stuff. Like in case of Microsoft, you cannot even avoid using it, like for SGX, for instance. So again, correct me if I'm wrong, but you cannot stand up an SGX enclave with Microsoft unless you're actually using Microsoft Azure attestation. So this kind of lock-in, it's not a strict up barrier to adoption like performance would be, but again, so friction just means that you're going to sell less software to fewer customers over a longer period of time. And now, even going back to attestation services, how many policy languages do you need? For every policy language, you need to know what your validation story is going to be, what your authoring story is going to be, right? How do you know that your policies are consistent between providers? How many attestation policy languages do we need? In fact, why can't it all be Rego? That was a question a customer is likely to ask. And again, on top of this, you're testing exactly the exact same stuff, the same hardware. Um, you also get different SLAs from different attestation services. And I keep pounding this point. An attestation service is an HSM of confidential computing. That's if that doesn't work for either performance or security reasons, or the whole edifice of confidential computing comes down. This is not okay. So the deep-pocketed customers faced with regulations, they will be okay. But with the barriers I just outlined, they will do sort of the absolute minimum, which is compliance. And what you want, of course, is you want a much broader, much faster adoption, because again, going back to the first point I made in this presentation, everybody wants it, everybody benefits. So then the question is, what can we do to make that dream come true sooner?